right, let's get started. All right, PS9 is out and is due the end of the week. It entails recursion. There are 2 problems, each worth 50 points. And PS10 will come out the end of this week and be due next week. And at that point, if you want to work with a partner on PS11, you're going to have to tell us. So find one now. Any questions or problems about anything? Okay. Okay, we're going to start talking today about a new topic, and that is polymorphism. So polymorphism looks like a foreign word maybe, and I guess it is because it comes from Greek. Oh, there it is. So poly means many, and morph means shape or form, and ism means the practice of. So it's the practice of creating program components that can take many forms. So it's sort of a general term that's applied to I'll show you some specific examples of polymorphism coming up here. So we're going to look at 3 forms of polymorphism in coming weeks. They are, first of all, generic, which you've already seen, inheritance, which we'll see today, and interfaces, which we'll see this week. So specifically, generics are an example of parametric polymorphism. The other 2 are examples of subtype polymorphism. Now, what I'm going to do is run through some slides here and try to explain the general idea behind generics and inheritance today. And then we're going to switch over to coding examples. And what I'm going to do is build a graphical user interface, a tip calculator. So a program with text boxes and buttons and such. And you may come away thinking that I've taught you about graphical user interfaces, and in a way I have. The lab tomorrow will be concerned with graphical user interfaces, and the assignment, PS10, will involve graphical user interfaces. But I'm doing this to illustrate inheritance, really, and ultimately interfaces. So the study of GUIs has 2 purposes. So I said you've already studied generics, and array lists and hash sets and tree maps are examples of generic classes. So back before there were such things as generics in programming languages, you would have had to define, if you wanted an array list of strings, you'd have an array list of string class, like a string array list. And then if you decided, I would like an array list of integers, and then you have an integer array list, or a big rat array list. So every one was a different implementation. And if you compare those implementations of, say, string array list and integer array list, how do you think they would compare? Are they very similar or very different? Yeah, very similar, virtually identical. Almost everything that goes into implementing a string array list is the same in integer array list, except for a few places where you use string to declare something, you would use integer. And this is how programming languages advance. Is a language exists, someone starts writing programs, people start writing programs, and they notice, this is a problem. I keep writing the same code over and over again with minor variations. It'd be nice if there's some way for the language to help with that. And that's what generics are for. So over here, we have the generic array list of arbitrary type. So that's array list is called generic type, and you can instantiate it with any class. So you write array list of t once, and then you let t be string, or t be integer, or t be big rat. You can essentially generate as many instantiations of that as you wish. So it's similar to methods. Methods take parameters. Generic types sort of take parameters, except they're the names of classes as opposed to values. So you should be familiar with generics by this point. And just to remind you, I don't want to belabor the point, but in Java, unfortunately, you can't have array lists of You can't instantiate a generic type with a primitive type. So you can't have array listed int, or array listed double, or array listed char. You've got to have, that's why wrapper classes exist, just to get around that limitation. And we've talked about that before. So let's talk about something we haven't talked about before, inheritance. So every class that you've seen me write and every class that you've written has started public class and then some class name like D, and then comes the body of the class, constructors, instance variables, methods. But you can, a class can also inherit from another class. So when I say public class D extends B, then that means something, and we're about to see what it means, but it's an example of inheritance. So when I say inheritance in Java, I mean defining a class using this extends directive. And I called this D because the class we're defining is called the derived class, and the class we're inheriting from is called the base class. So D and B suggest that. So in this case, D is inheriting from B. And the way to think about it is, when you see that, think about it as class D is exactly like class B, except. And the except goes here, the dot, dot, dots, tell you how the two classes differ. That's inheritance. So inheritance is useful when you have a class that exists, and you decide, you know, I would like to have a class just like this existing class, but I want it to be a little bit different. I want one method to behave differently. Or I want there to be an extra method. That's where you can use inheritance. Instead of copying the code and changing it slightly, use inheritance to change it slightly. And turns out you can't get very far writing graphical user interfaces in Java without using inheritance. So let's think about what inheritance means. So remember, let me go back here. D is a derived class. It's the new class you're creating. B is the base class, the existing class that you're extending. So let's suppose that B has instance variables age and name. D will now have three instance variables, age and name, which it inherits from the base class, plus the new one that we decide to add, is admin. So we inherit the stuff from the base class into the derived class. That means every D object will carry inside it an age, a name, and that is admin boolean right there. Even though the declaration of D doesn't even mention age and name. That's just there because we're extending D. Now, a D object may contain age and name, but they're still private to the B class, and so code in D cannot access the private instance variables that are inherited, but they're in the object nonetheless. You can't write any code inside D that can access B, but B's instance variables, but those instance variables are there nonetheless. Now, any non-private method in B is also part of D. So let's say that B defines a method F, a method G, a method H. All three of those are automatically part of D. Looks like I left off, F is private, right. So we get the public G and the public H in D for free. And so when you create a D object, you can invoke the method G on it, you can invoke the method H on it, and it runs just like it would on a D object. Plus you can add new methods, so I've added a print method. So in other words, when you define a derived class, you say, okay, I'm inheriting from this base class, and I inherit all the public methods, all the non-private methods I inherit, plus I can add others. So if I want to make a tweak to a class, I can do it with inheritance rather than with a text editor. Now, I realize I'm going kind of fast over this. I'm not showing you code examples. That's because I just want to show you the high points. So when we look at GUIs, I can remind you what we saw here. So bear with me here for a minute. You can also override what you inherit. So over there, I've created a D class that, yes, it inherits H, it replaces G with a new implementation. So the D's version of G is different from B's version of G, and then I add a new method print. Now here is the, when you do inheritance, it turns out that if D extends B, then what you should think is D is a kind of B. A D object is a kind of B object. It's also a kind of, it sort of has two identities. An object of type D can be used when you need an object of type D. It can also be used in any context that expects an object of type B. So if you have a method that expects a B as a parameter, you can pass in a D object because a D is a kind of a B. So what I'm showing there, if you declare an object X to be of type B, you could store a D object into it. And well, that just summarizes what I said. If a method expects a B object, you can pass a D object in. If a method is supposed to return a B object, you can return a D object. Because it's a kind of, a D is a kind of B. Now, yeah?
So what if like your parent object or whatever, the base object, what if that has like a public method, and that public method uses a private method in the implementation? The class that inherits it is not going to, is that public method still going to run?
Oh, the public method, yeah, you inherit the public method and its implementation. And that implementation will be able to access the
Even
private.
though it calls a private method and it doesn't have access to?
Yes. Now, why would it be, why is it safe to store a D object into that variable X? Wouldn't it be possible then to call some method on X that doesn't exist? I mean, I'm sorry, yeah. Couldn't you get in trouble trying to call methods on B? On an object of type, on a variable of type B. Let's go back to right here. Suppose we create a new D object and we store it into a B variable. What methods is it possible to call on that variable of type B? How do you look at that and tell? Yeah?
G and H.
Yeah, G and H. Those are the only methods you can call. And G and H are guaranteed to be defined in the class D. Now there also is the print method that's defining objects of type D. But when you take that object and store it in a variable of type B, those methods are inaccessible. The object is treated as an object of type B in that case. You have a question?
So if we have our base class, whatever, we tweak it with a derivative class, and then if we store a derivative object in a variable of type B, then we're basically just like trimming off whatever modification we made.
You're not physically trimming it off. You're making them inaccessible in that context. If you use an object of type D in a B context, only the aspects that are declared in B class are accessible. But the object retains its distinction. If you took that same object now and put it in a different context, all the methods would be available. Yeah?
It would be the original method G from the D object. We call G from D, which is, you know how we overrode it?
No, it would be the overridden version.
Oh.
Yeah. So there are a lot of fine points, and I'm happy to answer questions about them, but it's more natural to point out this as it occurs when we study actual code. Just trying to get some vocabulary built up here, give you a preview of what's going on. I'm going to stop there and actually look at some code. We'll come back to this maybe today, maybe next time. So here we are. So we're going to look at a simple GUI. So this is about as simple as a GUI gets here. I'm creating a tip calculator class. And what I want to do when it runs, I want to pop up a window that has a place to type the amount of the restaurant check, a place to type, a box to type the percentage tip you want to leave, a button to click on that says calculate tip, and then a place to display the answer. So a very simple kind of program. And this is my first take at it. So all I've done is defined a main method, and the main method does this. Now, you may have seen this. If you looked at the main methods in all the graphical programs you've used this semester, you would have seen a statement like that. Basically, that swing utilities.invoke later is, let me back up. Swing is the name for the user interface classes that you'll be using. So there's a set of classes in the Java library that are designed for creating graphical user interfaces. And actually, there are several such sets of classes. The set we'll be using is called swing. Invoke later means I'm going to give you some code. I want you to run it in a special way. So without getting too far into details, graphical user interfaces need to run on something called the GUI event thread. So that's the bottom line is this code right here is going to be executed on our behalf in the GUI event thread. It's not necessary to understand right now what a GUI event thread is, but we sort of invoke it in a strange way for that reason. You know, it would work. It wouldn't make any difference right now if we just ran it this way, which might be easier to look at. So we're going to create a new JFrame object and make it visible. Okay? Technically, that's the wrong way to do it. We should be doing it this way, so I'll do it this way. But fundamentally, that's what's happening. So let's run the program and see what happens. So up pops a JFrame window right here. Let me see if I can grab hold of it. Oh. It's got, here, I'll make it big. Let me grab it there. Okay. So that's what our application looks like so far. Just a blank window. But it does pop up. And our job is to make it run better. So what we're seeing is when you create well, you tell me, what is a JFrame object? Yeah?
Window.
Yeah, it's a window. So we created a window object and made it visible. If we didn't make it visible, there'd be nothing to see. So we first make it visible, and we first create it with the new JFrame part, and then we invoke the setVisible method on that to make it visible. Now, I don't want to have a plain old JFrame. I want to make something that's like a JFrame, but there's some differences. It's going to be like a JFrame in that it's got a window. Let me bring it up again so you can see. So the thing I want to create is going to, it's going to look like, it's going to be this. It's going to have this menu up here. It's going to have, minimize, maximize, X out. It's going to have a region to put things in. But I want it to be different. I want to have places to type input and places to a button to click. So I want to make a new class that's just like JFrame, except it has some differences. So that's a job for inheritance. Anytime you think, I want a class that's just like this class here, has the same methods of this class here, but I want to tweak some things, think inheritance. So how can I, let's just try this out. Let's make a new tip calculator object. Okay? Now what do you suppose that error is going to say? Yeah, it's going to say tip calculator has no setVisible method. And if I look at the hint, it's going to say, one thing I can do is create a method. I don't want to do that. What I'm going to do is come here and say extends JFrame. And my error goes away. Now, why did that error go away even though I didn't write a setVisible method? Yeah.
Because
setVisible is a method from JFrame. I just so if let me do this. Okay, I just declared a tip calculator variable, and I type t dot, and it's giving me all these methods here. Let's see, I've got action, add, a bunch of add methods, a apply resource, bounds, check image, contains, create volatile image, get alignment, get baseline, on and on and on and on and on and on and on it goes. Where did all those methods come from? JFrame. We inherited all that stuff. So just by writing that simple extends JFrame, tip calculator is effectively now the same as JFrame. It has all the methods of a JFrame. But what happened here? Oh, that's syntax error. So now when I run it, it should look the same. Okay? Haven't made any difference, haven't created any differences yet. All right, so let's write a, well, let me pause there and see if that makes some sense. So far I've created a new class called tip calculator that behaves the same thing as a JFrame. Okay. Now we need to customize it some, so let's create a constructor. It'll take no parameters. First thing, I'd like a title at the top. It says tip calculator. So let's see, there must be a set method, set title. There it is. So we can call that set title method as if it belonged, as if it were part of the tip calculator class, because it is. We inherited it. And now when we run it, I need to make it bigger so you can see it, but it says tip calculator up at the top. So now, working a little bit better. What else can we add to it? Okay, we need some kind of field. So there's a method called add. Let's see what it does. So add is a method that takes a component, whatever a component is, and adds it to the tip calculator. But I'm going to do something different first. I'm going to create something called a JPanel. So a JPanel is a region to which you can add components. So I'm going to add things to the JPanel, and then I'm going to add the JPanel to the tip calculator. So I'm going to say JPanel what happened to my mouse? There we go. That's bad. Sorry about this. Nothing to do but wait for it now. Are there any questions I could answer while we're waiting for Eclipse to start back up? Yeah?
So going back to when you're showing the base and the derived, assuming that you wanted your derived to behave exactly like the base, including the private thing, would you just implement the thing that behaves just like the private onto your derived class if you wanted it to be exactly the same?
So if I want a tip calculator to be exactly the same thing as JFrame?
No, I was going back to, I guess, the slides you were doing before.
Why don't we wait till I get back to those slides?
Oh, okay.
Since Eclipse came up in record time here. So. Okay.
I have a quick
Yep, go ahead.
question. Is there like a significant advantage to using the extension method or using JFrame methods rather than just importing JFrame and using it in your class?
Okay, so that's a great question. So you've always got two choices with your classes. I could have created the tip calculator class and added an instance variable of type JFrame and created the JFrame well, I should just do this instead of showing you, instead of telling you. I could do something like this. Suppose we did not extend JFrame. So I would have to do something like this. I would say JFrame have to do that. And then, let's see, there would be no set visible method, so I would have to take this out and put the set visible right here. Okay? And I got to pass a parameter. So that's another way to write the same class. And then I click run, and it's the same window. So the question is, should I, when you go to create a new class, should I create a class that contains a JFrame object? So I could make that an instance variable, for example. Do I create a class that contains a JFrame, or do I create a class that extends JFrame? And you've always, you've always got that decision to make. Now, in this case, either way will work pretty well. But I'm just doing extension today because I want to explain about it. However, the other thing that you get when you extend the class is the tip calculator becomes a JFrame object. And so if there's, say, some method that expects a JFrame, you'd be able to pass a tip calculator object to it and it would work. If I do it this way, though, that wouldn't work. But the general rule of thumb is, if you ask yourself, the question to ask is, do I want a tip calculator to be treated as a JFrame? If the answer is yes, do you extend? If the answer is no, you do what I did here. I'm going to go back to the way I had it before. I think that's it. Okay. So I was saying, okay, so I'm going to create an object called a JPanel. And there's an add method on JPanels that takes a component. So I need to add some sort of component, and the component I want to add is a I'm going to add a J label. Now, what I'm doing right now is just GUI stuff that's important if you're implementing a GUI, but I'm going to have more to say about it in a second. So I add that. Then I've got to set, no, I've already forgotten the name of the method. Set root pane. Set content pane. That's it. I don't do this that often. All right, let's run this and then we'll talk about it. So now up pops a window that has a label in it that says check amount. So that's our first start. So we can customize the one we're displaying to do that. But I want you to consider this line of code right here. The add method says it expects a component as a parameter. But what are we providing as a parameter? A JLabel. Okay? So what does that tell you about the relationship between a JLabel and a component? A JLabel is a kind of component. JLabel inherits from component. So this is where inheritance becomes really important. The set content, the add method on the JPanel class will accept any component. That means you can create a component and add it, or you can create a kind of component and add it. It could be a label, it could be a text box, it could be a button. All those are examples of components. It could even be a type of component that did not exist when Swing was created. So we could go off and create a completely different kind of widget. As long as it extends component, we'd be able to add it to JPanel even though it wasn't even conceived of when JPanel was created. That's the power of inheritance. Now, you can, when you use inheritance, you do some exploration. So I'm going to right-click on Tip Calculator here, and I'm going to go to Open Type Hierarchy. And it shows up over here on the left. I'm going to blow that up a little bit. And go up here and look at it. So look at that. It says, what that is showing you is that Tip Calculator is a kind of J-frame. We knew that. Tip Calculator extends J-frame. But also, J-frame extended frame. And frame extended window. And window extended container. And container extended component. And component extended object. That's called an inheritance hierarchy. So the methods in Tip Calculator, it inherited from all those classes back on its chain. Some of the methods it inherited from object. Some of the methods it provides were provided by container, and so on down the line. Every class ultimately inherits from object, whether you tell it to inherit from object or not. So every class you've written this semester inherits directly from object. That's the default if you don't say what it inherits from. So essentially, you could have written, every one of your classes, you could have written extends object, and it would have behaved exactly the same way. Can you tell me a method that your classes inherit from object? Yeah?
Get value of?
No, not get value of. What's that? Nope, not main. Yeah?
ToString.
ToString is the most common example. Okay? Think about it. You can append any object you want to a string. And the way that works is Java just calls ToString automatically on that object, converts it to a string, and appends it. And that works because every object has a ToString method, because object provides a ToString method. Now typically the default implementation of ToString isn't very good. It just prints out the name of the class and the location in memory, but you can override it. You can replace ToString with a better implementation. And that's called overriding, and we'll look at that later. So that's Tip Calculator. What do you think will happen if I do the same thing with JLabel? Let's try it out. So I'll right-click on JLabel. I will say Open Type Hierarchy. And there it is, a Tip Calculator. No, that's not right. Where I can see what I'm doing. I want JLabel, and I want to Open Type Hierarchy. What? Let me kill that, try again. I'll do quick type hierarchy and see what it does. That's too much information. This is bizarre. I'll try it. I'm having a good day. Okay, I'll do the quick outline. Oh. All right, this has more detail than I wish, but you can see a JLabel is a kind of J component, is a kind of container, is a kind of component, is a kind of object. So we can use a JLabel anywhere a component is asked for. Now what it's showing you down here is that a JLabel is also, these are showing you kinds of JLabels. So aligned label and aligned label is a kind of JLabel. More information than you need to see, but you know, that information is there, and let's go back to the code. So we're able to add a JLabel to a panel because it'll accept any old component. So let's try something else. Let's add a new component. Let's add a JText field. And let's see what it's complaining about. I need to import. And so I've added a second component. So And again, a JText field is ultimately a kind of component, so that works. We'll run it. And now you see we have check amount here and then sort of a very small text field. Well, that's no good. Let's make it bigger. I'll say give me 40. Pass that to constructor. Try again. Okay, that's too much, but you get the idea. So now we got a place to put the check amount. I'll make it half that. All right, what other fields do we need?
Percentage.
Okay, so I'm adding a new label. In fact, I'm going to add a pair of these, so I'll just copy. So we'll say tip percent. And we'll add that field. So now when we run it, we've got them like that. If I make it a little bit narrower, I can get them to line up a little bit better. Okay, check amount, tip percentage. What else do we need?
J button to calculate.
Okay, we need to put a button in and do the calculation. So that's yet another class. New J button. We'll call it, and this will be the name on it, calculate. I'll import that. So this is a third thing which is a kind of component. So we're adding text fields, J labels, and J buttons to this JPanel. And they all work perfectly fine. That you can pass it to add because add expects a component. If the designers of these three classes had not inherited from component, directly or indirectly, this wouldn't work. You can't add just anything to it. Let's see what that looks like. Okay, so now we got check amount, tip percentage, and calculate. And finally, we probably ought to add a new label that says total and a text field to display it in. Run it. And there we have it. That's sort of, well, not quite what I want it to look like, but you get the idea. Yeah?
How does it know which text field to associate with which label, J label?
Well, yeah, he's asking how does it know which text field to associate with which J label. We, the programmer, have to know that. Now, there are two ways we could, there are other questions though. Yeah?
Is there like a new line method or something?
He's asking, is there a new line method? And that's related to one of the things I'm about to talk about, so I'll put that on hold. All right, so one thing that's going to strike you right away is how klutzy that layout looks. You'd like to see the label maybe to the left of the box and have the boxes lined up on their left edges and have the buttons centered or something. This just looks like a hodgepodge, and it is. So that's one aspect of building a GUI I'm not going to talk about today. There are these things called layout managers in Java, in Swing. And essentially, by setting a layout manager, you can control where these things appear. And that's the subject of the lab tomorrow. Lab tomorrow, you're going to take something like this and learn how to use layout managers to make it look better. So I'm not going to worry about that today. We're going to focus on functionality, not that appearance isn't important, but I can only talk about so much. Okay? The other thing we're going to talk about is how to get this thing to actually calculate. And maybe I should try to find a way to get it to so you can read the font. So I actually don't remember exactly how to do that. So help me out. If you had this and you were wanting to make the font bigger, what would you try? What would you? Yeah.
Is there like a font class?
There is a font class. The question is, how do you change the font being used by this application? Yeah.
Could you just do panel draw the
Okay. We could. I'll start with just see if there's a set font method here. Okay. So I can do a set font. Let's say new font, and what does it take as parameters? A name. So I'm going to go with And then I need a style font dot plain and a size. I'll say 20. Let's see if this works. I don't really need the this dot. I just did that to get IntelliSense working. So let's run that. Nope. That doesn't work. Let's try panel.setFont. Nope. Well, I'm out of ideas. Do you have ideas? Yeah.
Would you want to set font before you get panel all of those?
So set the font before what?
So we panel that set font before panel that.
Let's try that. Yeah.
Maybe your text field has another constructor you could give it.
Perhaps, yeah. I don't want to start thrashing around right now, though. So what we're going to do is take a break. I'm going to look it up. All right, let's get started again. All right, so I looked it up and I remembered seeing it somewhere before, but the solution I found was too complicated. So instead, I'm just going to show you that I can increase the font size of a particular component. So I made check amount big, and we can do the same for the others. All right, I'll show you what I did here. I just created a new font, 30-point font, and then when I created the check label, I stored it in a variable, set the font, and then added it right there. Okay? So we need to do the same thing for these others. So I think there's actually a way to refactor. So let's copy this thing here. And let's see, if I go to Refactor, extract local variable. And we'll call it, what should we call that text field? Check amount. And it automatically creates a local variable, assigns it the value of that expression, and then puts the variable right there. And then we just got to do this. And we'll see how we're doing. Goodness, what happened? Not really my day. Yeah, let's change them all and see how it works. Refactor, extract local variable. It's going to be tip label. And we got to set the font. So this is very common. You know, you get a GUI to sort of work, and then you fix the problems till you get better at it than I am. Wait, what's going on here? Check amount, tip label. Oh, I see what happened. It put that field in twice, put it here and there. So the refactoring was a little bit too clever. So this is tip percentage. Not what I want to do either. Let's see what this is looking like. Okay, label, text field, label, text field. Not what I wanted to be doing here. Copy. Anyway, almost got it all there. Screwed up total somehow.
It still says tip label.
Yeah, on line 55.
Line 55, total label. Okay, so clearly this thing needs a layout manager. But I get all the information on there, and you can worry tomorrow about how to lay it out so it looks good. Okay? Sorry that I spent all that time doing that. Okay, so what's left to do? We got this nice looking, well, not so nice looking GUI, but it's got all the right stuff. Got to make it work, right? Okay? So let's think about how to make it work. We want to have something happen when the button is clicked. So when the button is clicked, what should happen? What's that?
Needs to calculate it.
Okay, it needs to grab the number out of the check amount, it needs to grab the tip percentage, do the calculation, and then display the result in that total box. So the question comes down as to how do you detect when the button has been clicked?
Listener.
All right, so so he said listener, so the answer is there's action listener, but let's get to that. So the button will tell us when it's been clicked. So we just got to find where the button is declared. That's calculate right here. And down here, maybe after we've done everything else, let's do this. So calculate has a method called add action listener, because calculate is a J button. And it takes an action listener as its parameter. So an action listener is a kind of object that provides exactly one method called action performed. So the deal is, if we have to pass an object to action listener here. That object has to be of type action listener. So we have to pass an action listener object to add action listener. Then when the button is clicked, the button automatically calls that listener object. That object has to provide a method called ActionPerformed. It calls that method, and that method is what has to do the work. So we've got to create or find an object of type ActionListener to pass to calculate. Okay? So let's just add a method down here. If you actually went and looked at ActionListener, you would say that you'd see that it wants a method called ActionPerform that takes an event as a parameter. And, well, that's not the right thing. And, now, I'm explaining this the wrong way. Let me go here. Let's look at ActionListener. Here it is. Okay, so ActionListener has exactly one method. It's called ActionPerformed, and it takes an action event as its parameter. But I want to show you something. This is new. ActionListener is not a class. ActionListener is an interface. So this is another form of polymorphism that was mentioned on the slides that we're getting to today. So we saw the form of polymorphism when you use generic methods. We saw the form of polymorphism when you use inheritance. And then there's this form when we use interfaces. So interfaces are sort of like classes, but they contain just lists of methods with no implementation. So if you looked at the code for ActionListener interface, it would just say void action performed action event E semicolon. There'd be no body. So an interface is just a list of methods. A class can choose to implement an interface. If a class implements an interface, it's obligated to implement the methods in the list. So let me show you how this will work out with our example. We are going to turn our tip calculator not just into a JFrame, but into an action listener. So if you write a class and you say at the top, implement some interface, then your obligation is to implement all the methods that are listed in the interface. But your reward, once you've implemented those methods, is now, in this case, a tip calculator object can be used as an action listener object. So it can be used in one context as an action listener object, another context as a JFrame, another context as a component, and so on. Now, why do you suppose action listener is underlined, besides the fact that it's not imported? Or why is tip calculator now underlined? Right, remember our obligation, what we're proclaiming to the world, a tip calculator is a kind of action listener. And we can't proclaim that unless we implement the methods that an action listener is supposed to have. And in particular, it's supposed to have a ActionPerform method. So what I can do here is hover the mouse, and it says, hint, tip calculator must implement the inherited method ActionPerformed. I'm going to click Add Unimplemented Methods, and what it will do is go down and declare that method for me. So I've added the appropriate method to the class. Since I have that method, I can now claim to be an action listener. And since tip calculators are action listeners, what object can we pass to add action listener? What we're going to tell the button is when the button is clicked, call the ActionPerform method on some object. What's a handy object we can give it? This. So what we're saying is, when the button is clicked, call the ActionPerform method of this object, of the JFrame object, of the tip calculator object. And so this will be called. And let's just make sure that the plumbing works. So I'm going to say console dot. I'm thinking the wrong language right now. Okay, so let's run it. There it is. I'll click the calculate button. I need to make the console, you can see it. And now that thing's disappeared. So now it detects the button click. So what's happened is we click the button. It's holding on to a reference to the tip calculator object. The button is, but it doesn't know it's a tip calculator. All the button knows is it's an action listener. And so when the button is clicked, it calls the ActionPerform method on the action listener that it has in its possession. And that is the tip calculator object. And so the method is called down here. ActionPerformed. So that closes the loop on our third form of polymorphism. Now, we don't want to be printing stuff out when that button is clicked. What do we want to be doing? Right, we need to do the calculating. So we need to go and get the, first we need to get the check amount. So how do we do that? We need two numbers, the check amount and the tip amount, tip percentage. So where would we go to find the check amount? Okay, so it's up here, it's in this, let's see, it's right here. It's, this JText field will contain whatever the user typed into that field. Okay, and that is called check amount. So let's come down here and say double check equals check amount dot, and it doesn't know what to do because it doesn't know what check amount is. What's the problem? It's declared right up here in the constructor. What's that? And it doesn't have anything to do with extension. This is a more mundane problem. Yeah?
Doesn't the user have to input
Well, yeah, the user's going to input something when it runs, but as it's running, I need to be able to go to this check amount object and pull out the number that they added.
You have to make it visible.
Yeah,
Check amount is outside the scope of that function.
right. This isn't visible. This is declared inside the calculator. It's not visible in this little method down here. So what's the fix? How can I make it so that the check amount object is visible in both methods? I need to make it into an instance variable. And you can refactor that too. So if I come to refactor and I say convert local field to local variable to field is what it says, it does it for me. So it removed the declaration of check amount and it stuck it up here in an instance variable. And so now it's accessible down here. So let's see what we can do with the check amount. So what we got to do is get text. So that'll get what the user typed. That's a string. Yeah? Right, we're going to have to parse it. So we're just using everything we know. We'll take the string, we'll parse it, we'll put it in that variable. Okay, that's good. What about tip? Same process up here. So here is tip percentage. This field right here, I need to make that an instance variable, and I could do it manually, but I'll just do it that way. So I just made it declared as an instance variable, and I'm going to have to do pretty much the same thing. Dot parse double, except this is tip percentage. And then I've got to say double total equals check plus check times, let's say tip divided by 100. Okay, so that's the total amount. How do we display it? Yeah? Well, this is where we're going to display it in this text field right here. So again, down here I want to say something like, oh, total is not going to work for me. Let's call this total amount. So what I want to say down here is total dot set text, something like that. But it doesn't know what total is again, so we're going to have to go again convert this to a instance variable. Refactor, convert local variable to field. And now this thing would be happy, except that's not a string, so I'm just going to, why not? Okay, now let's see how it works. All right, so let's say the check amount is $50 and the tip percentage is 18. Calculate and we get $59. I guess that's right. Okay, yeah.
Don't we need to look for exceptions?
Okay, so he just mentioned, what if there's an exception? What if the user types something other than a number right here? What's going to happen when I click calculate? So we had to come back here to see that it crashed. Say number format exception. Okay? We can worry about fixing that. Let me see what other questions there might be. Let me stop this. So I've got a bunch of stuff that I never, see I've got lots of processes running. So I'm killing it, hitting the double X to see the next one. I can tell you why that is here. I'm getting tired of this. Forget this. One little thing I forgot to do up here. When you create a JFrame, there's this method called set default close operation. And the operation is called exit on close. So what was happening before is when we tried to X out of the application, it was just hiding the window, but it wasn't actually ending the program. So this makes it so that Xing out actually kills the program. You don't end up with all these pent up things. Okay, so here we are. So we got the one problem identified. We could have an exception. What do we do? Okay. Any other things we should worry about here?
Negative
Yes.
tip amount.
Okay, what the tip amount's negative. Or for that matter, what the check amount's negative. Mhm.
Can you add anything to total? Or is total, can it be edited?
Okay, so he's saying, okay, someone could just come here and, type into that field. That field for display purposes only. Maybe we should prohibit users from typing there. So that one's easy to fix. Total label. So here's total. Let's see, set something. Set editable. So we'll say that it's false. So we're making it so it's not editable. We click, we look, and now it's it's there, but it's not designed to be edited. And it displays the answer for us. Okay? So playing around with GUIs, being able to discover what methods are available is invaluable. Okay? Well, let's make it more bulletproof. Let's make it so it won't crash when someone types something that's not a number in there. Where would we go to do that? Yeah?
Go where it tries to parse the double.
Yeah, we go here. So the various things we could do, I'm going to just put the whole thing in a big try block. So we'll catch a number format exception. Now doing it this way, we're not going to know which box had the problem, and so that's going to make it hard to, we can't give a precise information about where the problem is, but we can at least tell them there's a problem. And let's just pop up something to tell them. So you're used to using, when you want to pop up information to the user, how have you done that in your program so far? Right, you use the dialogues show message dialog. So I gave you those in a library because they're intended to be used, they're designed to be used outside of Swing. So your programs haven't been Swing applications, and so they're just written to pop those boxes up correctly outside of Swing. Inside of Swing, there's a method called JOption. There's a class called JOptionPane, OPTION, and I need to import it. Now, it's called show message dialog. And I need to import it. And it expects a component and an object. So you tell it what component to put the thing over, and that would be this object. And you tell it what to say, bad number entered, not the best. So now let's okay, so it was complaining there because I already had a variable called E up here, so I just called it EX. Run it, type bad stuff, let me calculate, and up pops the box and it says bad number entered. So it doesn't crash. Now you can say okay and go fix it. And it works. What would you do if you wanted to actually give feedback that said the check amount is negative, or the check amount is not a number, or the tip amount is not a number? You just need multiple try blocks, right? So right here, instead of having one try block wrapped around both of these parse doubles, you need one for each. Then you could tell which one caused the problem, and you could give a more definitive answer to explain what's going on. So you have to, when you're thinking about GUIs, there's some new stuff. You got this idea now that, okay, you write a bit of code, you can get the stuff to show up. There's this issue of creating a layout manager that you talk about in the lab next time to make it look better. And then there's the issue of making this method here, the ActionPerformer method, work right. What's going on inside here is just plain old-fashioned Java programming like I've been doing all semester. try blocks and calling methods and formatting strings and so forth. So you can't forget what you know. You just layer it on top. Now, those are all interesting details, or not interesting details, depending on your point of view. But I want you to remember the three main points of today's lecture were different types of polymorphism. And let's just go over what those three types are, and then we'll be done. So what three kinds of polymorphism did we see today? Okay, so we saw generics, and you've seen that before. Okay, inheritance, and where was that important today? Say it again. Okay, so we had tip calculator inherit from JFrame, so that a tip calculator now has all the methods of a JFrame object, plus any ones we want to add, such as ActionPerformed. And what was the third kind? Interfaces, and that was important because we had to have the tip calculator become a kind of action listener. For what reason? Why did it need to be, sorry about that, why did it need to be an action listener? To make the buttons work, because the button down here needs to have an action listener to notify. It needs an object to notify when the button is clicked. That object has to be a kind of action listener. And so one way to make that work is to make the tip calculator into an action listener by implementing an interface. Now, on Wednesday, we're going to revisit these topics concerning polymorphism. Try to explain them in more detail. Today, I just want to introduce the ideas to you. I'll tell you where we're headed. PS10 will involve implementing a game, a simple, basically one-player game with a GUI interface. So next week, you'll be writing this code. So I'll see you then.